Hello and welcome to the XD Indexer training from Ormex Systems. This video will teach you how to tune an axis and test motion with the digital scope and motion set. In this video, I will cover the tuning branch of the project tree as well as the digital scope. The tuning branch has the inertia calculator as well as simple and advanced tuning controls. The scope, found in the menu at the top of the window, allows you to plot data collected with the XD Indexer to make tuning easier and troubleshooting motion quicker. Every servo system is by definition a closed-loop system. When a discrete motion is commanded, the servo drive sends power to the motor to execute the motion at a specific acceleration and speed. Servo motors have a feedback device such as an encoder integrated into them to report position information to the drive in real time. As the motor begins to execute its move, the encoder begins reporting the motion. The drive does some math and determines how closely the motor is to tracking the programmed acceleration, speed, and position. This math is a complicated control algorithm that allows for stable and responsive motion. Because different mechanical systems react differently to commanded motions and outside disturbances, this algorithm has gains that require adjustment, or what we call tuning. Let's take a look at the tuning branch and motion set. To simplify the work involved in tuning all the gains in the control algorithm, motion set has what we call simple mode. By executing a motion, the XD Indexer calculates the inertia of the load automatically. By clicking Use Calculated Inertia, gains within the control algorithm are adjusted automatically for you. Then the system can be modified to be more stable or more responsive based on your application requirements by moving this tuning slider left or right. Let's take a look at an example. First, let's launch the scope. Click this icon in the menu at the top of the screen. When the scope opens up, it will look like this. On the right, I will select some parameters I want to plot to tune the system. I have 4 channels available. The first one I will use for monitoring current so that I can see how hard the motor is working. The second will be the velocity command, or the ideal velocity set from the drive. I'll set the third channel to velocity actual so I can see how I fare against the ideal. Lastly, I will set the fourth channel to position error so I can see how far behind I am lagging in terms of position. At the bottom of the screen on the left, I can tell the system when to begin collecting data. For this exercise, I want to trigger the scope when motion is initiated, so I will leave this alone. Moving towards the right, I can specify how often to collect data. Keep in mind that the sample size is 512, so the closer together the samples are, the shorter time period will be traced. Moving further right are the digital I/O. If I had set channels above to record I/O status, like this, then I would be able to visually see the I/O come on and off as I move the cursor in the scope area left to right. In this case, we will not see any changes in I/O. Finally, if I need to save screen space, I can click the button labeled Small to shrink the scope into mini mode. To begin, I have programmed a simple relative motion in motion 0 and motion 1 and chain them together. For this example, motion 0 will move the axis 1,000 hundredths of an inch, or in other words 10 inches, in the positive direction at a top speed of 15 inches per second, dwell for 100 milliseconds, then chain to motion 1 that will move the axis 1,000 hundredths of an inch back to 0 at 15 inches per second. Initially, the motion looks like this in the scope. Here, I can see that with the fast acceleration and deceleration, we accumulate some position error. Our velocity curve also exhibits some poor motor performance, while the current consumption of the motor is relatively low. Looking at the tuning screen, I can select Use Calculated Inertia and run the motion again to see a significant improvement in performance. Keep in mind that the inertia calculator in the XD Indexer uses an iterative calculation, so it is best to trigger the move and click the Use Calculated Inertia button 3 or 4 times to really dial it in. If this performance level will not meet your application needs, then the velocity loop gain slider can be moved to the left for more stability or to the right for more performance. To make this change apparent, I will show you the extreme case. If I move the slider to the left significantly, I can see the changes in the plot. Following error increases and current consumption is relatively smooth. If I move the slider to the right, following error decreases, but the current consumption of the motor becomes more unstable. If pushed too far to the right, the motor will become unstable, first by emitting an audible whine, then by erratic motion. This is a good time to remind you that tuning should be performed slow and deliberate with appropriate safety precautions taken to ensure the safety of yourself and colleagues as well as the machine itself. For applications that require performance that cannot be reached with this simple mode of tuning, an advanced mode is available. This screen allows you to change specific gains and filters. Performance can be enhanced on this screen, but only advanced users should attempt changing these values, and consulting with an Ormec engineer is strongly recommended. I would like to point out a few more things about the scope before this video concludes. Traces can be saved and later loaded if performance curves are a required element of the machine documentation, or you would like to show a specific behavior on the machine to your Ormec engineer. In the upper right corner of the scope window, there are a few settings you can use to customize the scope. Autoscale will automatically resize plots in the window to fit the screen. Markers can improve the visibility of some plots. Frequency plot can be used to identify resonance on the machine, and overlay will retain a ghost image of the previous trace for comparison over time. You can change the display values at the bottom of the scope plot area to display the first or last value plotted, or return the value that is at the cursor, wherever that is at the moment. On the Options tab, the display can be changed by adjusting these settings. Here, a filter can be applied to the current velocity actual data logged by the indexer. Out in the plot area, several additional tools are available by right-clicking. Zooming, panning, and multiple cursors allow you to make precise measurements of events plotted in the scope. This concludes this instructional video. For more information about how to use the XD Indexer, visit us at ormec.com.